Hi everyone. So it's been a very long time that I was not able to shoot a video because I was shifting to Dublin. I just started my masters in computer science in UCD. So I was busy with my academics and I was not able to shoot any content. Now I take out some time from academics and I again started. So I created one playlist. In this playlist we are going to study about the Apache Kafka. And this playlist contains 3 videos. In the first video we are going to see the fundamentals of the Apache Kafka, and this video is going to be enough to understand the fundamentals of Apache Kafka. So second video will focus on the interviews. We will study about what are the type of questions that interview ask in the interview related to Apache Kafka. Third video, we are going to set up Apache Kafka on our local machine and we will just run and do some partitions, and we'll do some publish and subscribe and every single thing. Just going to be a small setup of Apache Kafka so that you can get the basic understanding. So this is all about the playlist, and without wasting any time, let's get started and study. So we are going to understand Apache Kafka with very simple example, and this example we are going to use for the whole video, and with this simple example you will understand the requirement of the Apache Kafka and why it is so important in this industry. So first of all, let's take an example of an e-commerce platform. In this e-commerce platform we have multiple microservices like order service, payments, notification, inventory, and the analytics service. Now a user come and make an order to our e-commerce platform. So what will happen? Suppose that there is an API of orders, that we can say that the user will hit that order API to make an order. Whenever we user is placing an order, the request will go to the order service. Order has been placed, but the order can be placed only if the payment has been completed. So if we talk about the function, so it will say the function order first of all will create some entries in the order service, and after that will call the payment service, and whenever the payment is completed we will say the order has been completed. So order service will send an call an API to the payment service, and it will wait. Order service will wait till the time the payment service is going to respond. So let's say payment service has responded that order payment has been successful. After that the payment service will send to a notification, a simple notification that user's money has been debited. And after that, when the payment service will respond back, the payment service will respond back to the order service that the payment has been deducted. Now we can say the order has been successfully placed. So order service will also send a notification. So did you see that there are two notifications are happening? Payment service is sending their own notification, order service is sending their own notification, and they are doing by their separate services. Now payment service also wants to push some data to the analytics service. Order service also want to push the data to the analytics service. Payment service is sending the data by itself and order service is sending by itself, and after that order service push the data to the inventory service. So this is the whole flow. Now if I make a simple function for the order service, it will simply look something like this. First function, let's say order service, so some basic content. After that we will call the payment service. When the payment is completed we'll call the notification service. When the notification is completed we'll call the analytics service, and after that we'll call the inventory service. This is the whole flow that the order service will follow while to make a complete order. Now this approach looks very good when we have a very small scale system, but there are going to be some problems. So let's talk about these problems that we are going to face. So first problem that is going to be faced is going to be high coupling. So did you see, to place an order we are dependent on the payment service, we are dependent on the notification service, we are dependent on the analytics service, we are dependent on the inventory service. So let's take an example that our analytics service is down right now, and if we want to make an order, in that case a user will come place an order. So but our function will fail. Our function will fail because analytics service will not able to respond, and analytics service APIs are going to be fail right now because it's down. So what will happen in that case? We are not able to process an order because only our one service is down. Everything is very tight coupled and we don't want that. Second one is every operation is in linear manner. So when I wrote that function order, so everything is happening in a linear fashion. So first when the order service is going to call the payment service, then notification service, then analytics service, and then the inventory service. Like if I understand the thing that order service should be dependent on the payment service, so it should be linear, like order should be completed whenever the payment has been processed. Okay, so we can say that it should be linear, so we can go with the API. But what about the notifications, analytics, and inventory? These three things are the separate tasks. Like our order has been successful, now we can send it to analytics. At the same time I can send this to notification, at the same times I can send it to inventory. I don't want to go into a linear fashion. And if we want to do it into a code, we have to like write some crons, or like we can say we have to like run multiple threads, or we have to do some asynchronous programming. We have to do a lot of things to hit 3 APIs in parallel. Third point is single point of failure. Again, the single point of failure, again we can say our analytics service is down. Because of this whole service, our whole system, we cannot process the order. This is the example of a single point of failure. It is quite similar to tight coupling. Now, fourth point is losing data. Think about it that again our analytics service is down right now, and if we want to place an order and somehow we figure it out that let's not push the data to analytics service for some time because it's down. Like we don't want to push the data to analytics service for let's say for 1 hour because it's down right now. We can just take the orders, we can put it to payment service, notification, and inventory service. But at that for 1 hour we are going to process the order, but the whole problem now is that we are going to lose the data for 1 hour. So this is going to be the problem of losing the data. Now we discuss the problems. These are the problem that we are going to face in our distributed system. This e-commerce platform is an example of a distributed system that is working with the help of the APIs, or you can say some other protocols. Now, to solve this problem, we need some different kind of architecture. So we will move distributed system. We are going to solve this problem with the help of streaming data platform. And this streaming data platform, there are many streaming data platforms available, and one of them is Apache Kafka. So what can be the definition of Apache Kafka? That it is developed by LinkedIn and now managed by Apache. This worked on distributed system and provide streaming of data. So we know the problem in the whole model. Now let's solve them one by one and understand what is the approach that we are going to use now. So now we know, again we have to process an order, the same example, and we know very well that it is dependent on the payment service. So we call the API of the payment service, return it back, and we'll say that the order has been successful, payment has been successful. So we'll just mark it as success and success. Now what happened? I place an order, hit an API, both the things are success. Now, instead of hitting so many APIs here, it is a very small distributed architecture. That's why you can see just some simple arrows, but there can be many microservices, many arrows. Like, so it's a very small e-commerce platform. That's why we are seeing only 5-6 arrows, because there are only 5 microservices. But in like big company like Netflix, there will be like 100 of microservices and they are communicating with each other. So now what we are going to do is this order service is going to provide the data that this, let's say there will be data like order 1, and let's say it will be at the timestamp, let's say 10, and the data, or we can say amount or something. Okay, and we'll say status equals to success. So this type of data will send into the Kafka. So the data will go to the Kafka. Payment will also send the data to the Kafka. In the format will be different, of course. The format will be like something like that. We can say the sender ID equals to, let's say, ABC, receiver ID equals to PQR or something, and the amount that we are deducting. So payment service will send their event, and order service will send their event to the Kafka. So these order service and the payment service are going to publish those events in the Kafka. And now Kafka service is going to send those events to the inventory service, notification service, and the analytics service. Now we know that inventory service wants the only order. So inventory service will only get the orders Our notification service will get both orders and the payments, and analytics service will both get the orders and the payments event. This is something that is going to happen. We will see how it is going to happen, but it is all happening with the help of the Kafka. And like we can consider that Kafka is a small bucket. In this bucket, we are putting both the events, order events and the payments events. Okay, but the whole problem with this bucket is that it is going to be a single bucket. Now we have both the events in that. So let's say there can be multiple service, and multiple service is going to put every single thing into a single bucket, and after that bucket we have to like figure it out, like this particular message will go to these three services, this message will goes to these two services. So it is going to be very difficult. Now we have to change the solution. So let's take one more example to understand it. So the example can be, suppose that you go to a bank. In that bank there is one single counter. On that counter the cashier is also taking a money, and there is one person solving the loan problem on the same counter, and there is a very long queue. So let's say the first person wants some cash, goes to the counter, takes the cash. Another person wants to solve the loan problem, again goes to the same counter, solving the loan problem. And like, so we can say orders, payment, order, payment, payment. This is a queue. Now, but the counter is one. So what we can do is, now we can make two separate counters. One counter one will solve the cash problem, and other counter will solve all the loan problem. This is the second approach that we can take. It means we can make two separate buckets. One bucket will take all the events from the order service, and other bucket will take all the orders from the payment service. This is the approach that we are going to take. So now this architecture is looking a little bit big, but it is also quite easy to understand. Instead of bucket, I make a small queue and I named it as topic 1 and topic 2. But the concept is same. In this bucket, we are just added two things. First thing is going to be, everything is going to be in a queue so that it can follow the FIFO fashion, first in, first out. Secondly is there going to be two buckets. First bucket is going to consider orders, and second bucket is going to consider the payment service events. So the services in our distributed system that are going to produce the events, in our case that are order service and our payment service. So we will say them producers because they are producing the events. Kafka is going to do some work. It is going to manage the bucket, and these buckets we can say call them topics. And we can define topics in Kafka as containers that are made to perform one single task. So these are the queues that are made to perform one similar task. So topic 1 is going to perform task related to order service, and topic 2 is going to solve a task related to the payment service. So this is my bucket 1, or you can say topic 1, and this is my topic 2, or you can say bucket 2. This is known as topics in Kafka. And in the Kafka, there is the third thing that is going to be the consumer. Which are the services that are going to consume the topics? So consumer is going to be inventory, notification, and the analytics service again. But the point is, notification service is going to consume from both the topic 1 and topic 2. This analytics service is also going to consume from both the topics, topic 1 and topic 2. And this inventory service is going to consume the topic from only topic 1. And after consuming the messages, these services can perform their specific tasks. Let's say notification service will get the data on the topic 1. It will like perform and send the notification to the user that your like order has been placed. If we get that on the topic 2, they can simply say the payment has been deducted type of notification. It can save to the order analytics data. It can save it to payment analytics data. Anything can happen because these are the services and they have their own code. And now the services which are going to consume the messages are known as the consumers. So whenever we make the consumers in the Kafka, so these services are going to register them in themselves into the Kafka, and they will mark themselves that we want the messages from topic 1. This notification, when going to be registered into the into the Kafka, it will mark itself that I want the messages from both the topics, topic 1 and topic 2. And analytics service will mark again topic 1 and topic 4. Like I want messages from both the topics. And inventory service will mark that I want message only from the topic 1. This is a simple mechanism that is going to work. Now let's understand the fourth fundamental point, that is partitioning in Kafka. So till the time what we have studied, first concept was that we have only one counter, okay, and then the counter, what we noticed that we have orders and let's say payments, orders, payments and payments, order. So this was our queue. To solve this problem, what we did, we made two different counter, let's say orders counter and let's say payments counter. So we have orders, payments. But still, what we came to know that there are a lot of orders and there are a lot of payments events are coming, because like there are multiple microservices sending multiple orders, multiple payments is happening. So like there are like millions of orders are coming, millions of payments events are coming, millions of things are happening. To solve this problem, we came to the concept of partitioning. So the whole idea is, in this counter, let's make it a cabin, and now into this cabin we have three counters of orders and three counters of the payments. So it is going to be simple as that we hire multiple people. So now this is going to be my order counter 1, order counter 2. Again we can say payment counter 1, payment counter 2, and this is whole as known as, let's say we can say again people are going to the counter 1, we can say order. We can say payments events are coming to this counter, payments events are coming to this counter, orders event are coming to this counter, and these two things are segregated because they are two separate buckets that we have studied. These buckets are known as again topics, and in this buckets we also make some small segregations of the bucket. We can say we have a very large queue and we divided that queue into small queues that are known as partitions. So it is pretty simple. We have order topic. Now in the order topic, we send it to either partition 1 or partition 2, and the payment topic, there will be again partition 1, partition 2, partition 3. We can make multiple partitions into one same topic. We divided it, and now what will happen? We have an inventory service that will take from the order topic, and we have a notification service that will take from our order topic and the payment service that we have already studied the concept of the consumers. Now what will happen? When it was getting the data from the topic, all the three partition 1, partition 2 and partition 3 will send to the consumers. All the three partition will send the data to the notification service, and all the ordered services is going to send the data to any of the partition. Maybe they can send it to partition 1, maybe they can send it to partition 2, and the payment service can also send the data to the partition 1, 2 or 3. Anything is possible. But still we have divided the whole topic into multiple partitions and our payments topic into multiple 3 partitions. This is something that we have did. Let's see what are the problems that it is going to solve. Slowly the model is getting bigger, but if you will just like see this example slowly, you will able to understand it. Now let's talk about the consumer groups. Now what is happening? We discussed till now about this thing topic. We discussed till now about the topic and the partitions. Now let's understand how these partitions are going to solve the problem. Now we know that we have millions of operations happening. So it means that there are multiple instances running of the order services, multiple instances running of the payment services. It means that multiple people are sending the payments at the same time, so that we have multiple instances, like multiple payment services are running in parallel, something like that. Now every service is going to send the payments to, let's say, payment like partition 1, partition 2 and partition 3. So that the load is too much, what we'll do, we will also, so that we have to send the more notification, so our multiple notification services are running now. So what we'll do, we will make the consumer groups. So this square box entity is known as the consumer group. So what is this consumer group is going to solve? Let's understand it. So let's say we have a message A1, let's say we have a message 1 here in this partition 1 right now. So let's say we have a message 2 here and a message 3 in this partition. We have 3 separate messages in this partition. So we send this notification service, this notification one service is going to consume this particular message, one message. So how Kafka will know that we send this message to the notification one service and we don't have to send this one message to this notification two service? This is something that Kafka. So we have sent this message to the one service and the same message we should have to not send into the second notification service. To solve this problem, Kafka maintain a consumer group. So consumer group says that every consumer group will only receive message one time, receive message once. So this is the simple example of the consumer group. So what we do, we make the consumer groups like this. So notifications will have their one consumer group, and whenever this partition one is going to send the message to the consumer group, so consumer group will respond that I received the message in one of the consumer. Maybe there can be multiple consumers, there can be, let's say, multiple notification services. So we can simply say that one of the consumer have received this message. So Kafka, please don't send it one more time to me. Let's say this second message will receive by the consumer 2, this third message is received by the, let's say, by the first consumer. So we can simply say you don't have to send it to me again. This is a simple example of the consumer group. Now we have studied every single thing. We will revise it and then we will move to the what are the Kafka brokers, and this is the final architecture and we finally reach to it. So let's see it. First of all, I'll just make you revise every single thing one more time and then we will understand the brokers, and this is the final concept, and once you understand it, everything will be clear to you. First of all, we have order service that is acting as a producer because it is going to produce some events. This order service is going to send an event to a topic. This is my topic, and topic is going to be divided into small pieces, or you can say small queues. There is one large queue that is going to be divided into small queues, that is known as the partitions. So we have partition 1 and partition 2. We divided the partition. When we divide this partition, now let's say we have this order 1 here, order 2 here, order 3 here, order 4 here, 5 here, something like this. Now after that we studied about the consumers. So Kafka registered consumer that we have to send this particular topic data to some of the consumer, the companies who have registered, like the services who have registered to consume this particular topic. So let's say inventory service want to receive this topic, let's say topic 1 order topic wants to receive this. So and when we are like sending the data, so this inventory service, we started sending the data to the inventory service. So this inventory service will say it is known as the consumer. But when the load is increasing, so we will have multiple order service. So but these order service are going to send to the same topic T1. So these 3 order services are going to send to the T1, and this partition is already scaled, means we in a topic we have already made the partition, so we already talked about the scalability of it. But when we talk about the consuming, so we will have multiple inventory services. So when we have a multiple inventory services, then we make our consumer group, and in the consumer group what we say, whenever one of the consumer have received the message, we will not send the message to another consumer. So let's say this inventory message has received this message 1. So another consumer, let's say this consumer inventory service will not receive this message 1. This is all happening with the help of this consumer group feature. Okay, so we discussed about the consumer group, topics, partitions, producers, and the consumers. So now let's talk about the brokers. So till the time when we were talking about the topics, producers, and consumers, everything was pretty sorted. But when we did partitions, why we need partitions? We need partitions so that we can scale. Okay, we need the consumer groups so that we can scale on the basis of the consumers. Now on the basis of the producers, we are just producing on one single topic, but we can also produce on directly to the partitions. We can also do that. Okay, Kafka gives this functionality. So we are scaling at the producing end, we are scaling on the consumer ends, we are scaling on the topics end, but are we scaling the whole Kafka? And how we can scale a service? But we can scale it with the help of when we can make a cluster. So when we make a Kafka cluster, so it means that we have three services now. We have one service, we have two services, and we have three services of Kafka. So in the first service, we have of course the topic one. Everything was working same in the topic one. We have again the partition. We have multiple topics. We have order topic. Let's say there is one more topic, topic two, and we can just simply say in the topic two there will be like, let's say, no partitions, and there will be, let's say, payment topic. So the first thing is the Kafka is cluster. So Kafka is cluster. I'll just write it with my white pen. So Kafka is clustered. Why Kafka should be clustered? Because we can scale with the help of the clustered architecture. Because at the order services are also clustered. Inventory services, we have multiple inventory services running. Kafka should also have multiple services. And these services, in terms of Kafka, we call them brokers. Okay, so these services that I'm talking about that are running into a Kafka clusters are known as brokers. Brokers is equals to services that are running under Kafka clusters. Okay, I think this point is clear. Now let's move to the second point, that is this T1 is going to be into one of the broker. Let's say the topic 1 exists in broker 1 and everything is till the time is solving into this broker 1. Now what happened? There are three services running. Let's say topic 1 have the broker 1, broker 2 and broker 3. Three different services are running and they all manages their own topics. Okay, they are not connecting with each other. So let's say our order service is connecting with directly with the broker 1 and consumers are directly like taking the data from the broker 1, or you can say the topic 1 that is into broker 1. Now what will happen? Let's say broker will go down. So don't you think the data that is into the topic 1 right now will be lost? Because the data will be lost because the broker 1 is down. So are we able to solve the problem of fault tolerance? No, because there will be no data replication happening. So we understand one thing. These other brokers are acting as the followers of the broker 1. So let's say the broker 1, so we can say broker 1 will act as a leader and broker 2 and broker 3 will act as a follower in that case. Now that is all we are talking about the topic 1. So for the topic 1 we just simply say that broker 1 will be the leader, and in the topic in the broker 2 and in the broker 3 what we will do, we will just replicate the same topic, okay, so that we can attain the fault tolerance. What is the fault tolerance? Let's say the broker 1 goes down, still we have the whole data of the same topic. So all the topics will exist in all the three brokers. Okay, so broker 1 will have the topics and it will do all the read and write operations, but all the data of that topic will also be replicated to the broker 2 and broker 3. Remember one thing, for this topic 1 we have broker 1 as the leader. Okay, but let's say there is another service, let's say payment service. Let's say we have a payment service and payment service has a different topic, let's say T2, and let's say I'm just mentioning one topic, let's say T2 here. Okay, it is into broker 2. Maybe the broker 2 will act as a leader for this topic, T2 topic. So broker 1 will act as a follower for this T2 topic because broker 2 is a leader for T2 topic and broker 1 will act as a follower. Similarly, broker 3 will act as a follower for this T2 topic. So these broker 3 and broker 1 will also have this T2 topics, and of course the partitions as well. Like T2 topics mean T2 topics and their partitions, and here also broker 3 will also have T2 topic and their partitions. This is how the replication is going to happen, and Kafka is also going to achieve the fault tolerance. Now we have the clustered architecture in the Kafka. So we need something to manage all these clusters, because there are three services running there. The replication is happening of the data, the topic. Whenever the data is coming to, let's say, topic 1, it is going to be replicated to, like, let's say the data is going to come to the broker 1 and the topic 1. It is going to be replicated to broker 2 and to the topic 1. Now, this all the things are happening now. Now we need a system that can manage all these three clusters, and we can have multiple clusters. For that management, the Kafka use internally Zookeeper. Zookeeper will maintain all the three brokers, all the three configurations of these, all the three brokers. Okay, so let's say there will be a topic, it will go to the broker 1 and the replication will be maintained into broker 2 and broker 3. So these all the metadata is going to be stored into the Zookeeper. Now, previously Kafka was using the Zookeeper, but now in the new versions of the Kafka is going to use the KRaft, by which it is going to manage the whole. So you don't have to download the Zookeeper externally to run the Kafka for the local setup. It is simple as that. I think you understand the clustered architecture of the Kafka, the replication, and every single thing, and why the Kafka is fault tolerant. I will also write this point, the fault tolerant. So now let's understand the difference between the Kafka and SQS. So Kafka works on the publish and subscribe model. The multiple services can publish on a topic and multiple services can subscribe from the topic. For the SQS, it is a simple queue. Multiple services can publish to a topic, but only one service can subscribe to a topic, because once the message, like multiple services can subscribe, but once the message has been subscribed by any of the service, it will be deleted from that particular queue. Okay, but in the Kafka, we have a retention policy. This is a retention.ms keyword. So it means that whenever we set the retention.ms value in the Kafka configuration equals to -1, it means the data is never going to be deleted. It is going to be stored into the topics, into the brokers. And remember, the brokers is going to work into the leader followers, and it is going to be in all the three followers. It is going to be present in all the three brokers if we have a three broker setup of Kafka, because Kafka is fault tolerant. It try to be fault tolerant. Now let's say if we set the value retention.ms equals to 604800000 something, it means 7 days. We want to store a message into a topic for 7 days. We can do that too. If we don't want to store a message, if it's consumed, like if it's not a very tough task, if the data is not that important, there is no need to store the message. But Kafka gives this functionality to store the message for some days, for lifetime. So the example is simple of the streaming platform is Kafka, and for the queues we have Amazon SQS. So now let's talk about the last part of this video, that is offset. So to understand this, we will deep dive into the topics and we will understand what is offset. So this is my topic. In this topic, let's say this is an order topic, and in the order topic we have partitions. We have already studied that we divide the queue into multiple queues. Like topic is a very big queue, so we divide it into multiple queues that are partitions. Now what is going to happen? Multiple producers are going to put the data into the partitions. So let's say producer 1 put the data into this partition. So order 1 and order 3 is going to be in this partition 1. But producer 2 will put the data into this partition. So let's say order 2, 4, 5, 6 are going to present into the partition 2. Now we make our consumer group. So this is our consumer group, and we have three consumer 1, 2 and 3. Let the name of the consumer group is, let's say, order consumer. So first thing that of course I'm going to tell you into the interview video, that we generally don't make more consumers than the number of partitions. We'll come to it, like why we don't do that in our interview video. So but I'm just letting you know that if we have 2 partitions, so we generally make 2 consumers only. We don't go for 3 consumers. Okay, so let's say we have now 1 consumer group and 3 consumers in it and 2 partitions. Now what will happen? We studied about the consumer group. Whenever let's say this order 1 is going to be consumed by this, let's say consumer 1, so it cannot be consumed by consumer 2 and consumer 3. So this is a feature that is provided by the Kafka, that only 1 consumer in a consumer group can consume a message, and all the other consumers cannot consume the same message again. So how Kafka is doing it internally? Kafka follow the concept of the offset. So Kafka stores some internal data into the table known as the consumer offset. So this is an internal topic, and how this internal topics look, let's understand it. So it store the name of the consumer group. Name of the consumer group is order consumer. So this is the name of the consumer group. Secondly, the name of the topic. The name of the topic is order that we stored in this table. So why we need these two columns? Because one consumer group can also consume another topic data also. So it means that order consumer group can also consume the orders from, let's say, topic from payment topic as well. Okay. So one consumer group can contain the data from multiple topics. Okay. So that's why we have the topic column as well. So in this topic, we have multiple partitions. So let's say we have partition 1, partition 2. We have partition 1 and partition 2. So these two are coming here. Now we are maintaining the offset. So let's say from this partition 1, we have this consumer 1 has received this order 1. So we'll mark that offset is 1 right now because one message has been received. Okay, or you can say simply 0. Let's say 0 base indexing we have received the first message because message is present as the 0th index. Okay, otherwise the value will be null. Okay, here the 2 means partition the value equal to 3 means that all the 3 messages has been received, but we don't know which of the consumers have received. I don't know the consumer 1 has received, 2 has received, or 3 has received, but we know that the whole consumer group has received one of this message, like all the partition 2 has been cleared. Now let's say we have a message in the partition 1 order 3. So let's say any of the one of the consumer will receive the message. Let's say consumer 1 or consumer 2, any one of them have received the message. So what we'll do, we will just increment the offset to 1. Now it means that any of the one of the consumers in the order consumer group has received the message and the offset value will increase. So as you're seeing, whenever we are sending the message to the consumer, we are incrementing the offset. Now Kafka provide both the feature. First feature is we can increment the offset whenever we are sending the message, or the second feature that Kafka provides is that we can increment the offset whenever one of the consumer is going to process on that particular message and send us the callback. So it means that let's say the event is very important, or you can say the message is very important, and one of the consumer has consumed the message, and whenever the consumer will send the callback that I process this message successfully, now you can increment the offset. So Kafka provides both the functionalities into it. So now let's understand why we need the concept of offset. So first is to track what has been consumed till now. So by maintaining the offset, we know that the 1 means that we in the partition 1 we have consumed till 2 messages. Let's say we have the offset equals to 4, so we know that we have consumed till 4 messages in the partition 1. So now we have to consume more message, like we have to consume from the 5 or 6. Same is avoid message duplication. That is the second point. So let's say with the help of this offset feature, now we know that we have consumed the order 3. Okay, we are on the offset 1. Now we know that very well. We don't have to send this message to any of the consumer because we have incremented the offset. The most important feature is replay message. For this, I think we were studying the topic of offset. This is the most important feature. So let's say, because let's say in a whole day between 12 to 1 p.m. there was some error occurring at the database level, and we are not able to process the orders properly, or let's say the topics properly, or we can say the events were not able to process between 12 to 1 properly, and we just figure it out. Let's say the order number 1000 to order number 3000, what the range of the orders between 12 to 1. So what we can do, we can just go back with the help of this replay message functionality in the offset. We can just change the value from 1000 to 3000 and we can replay those messages. So this is the feature that is provided by the Kafka. We can replay, or we can just run the segment of messages one more time. We can just run, like, let's say I missed some, let's say last 500 messages. I can just replay them. Okay, so this is one of the feature. Fourth feature is the fault tolerance, and fifth feature is the order guarantee, because we are maintaining the offset, so we know that this message has been already delivered or not. Now, so I think this is all for the video. In this video, we covered a lot of topics like producers, consumers, topic, partitions, let's say offset, consumer group, broker, how clustered architecture work, what is the replication, and like so on. So this is all for it. In the next video, we are going to see what interviewers are expecting from you. Okay, maybe they can ask you the fundamentals and the questions, but there are some questions that they can ask related to Apache Kafka. So I can give you like one example why what kind of questions that interviewers ask in the interviews related to Apache Kafka. Like how many partitions we required, like if we have that much of load into a single topic. So till the time we have just studied that we can make 2 partitions or 3 partitions. But what's the logic behind it? Why we need only 2? Why we need only 3? Why we don't need 7 partitions or 8 partitions? Why only 3 clustered setup of Kafka? Why not 5 clustered setup of Kafka? And so on. Why we cannot make 2 clustered setup of Kafka? So these are the some of the questions that we are going to answer into the interview video. So I'll see you in that video too. Okay. So thank you for watching me, and let's meet in our next video, and bye bye.